Hello everyone, this is the second installment of Training Stress Balance Workbook in Microsoft Excel. In the last part I've been talking about two different methods of calculating chronic and acute training load by using either average or sum function and underlying assumption. In this installment I'm going to talk a little bit like I actually found one simple solution how to kind of combine both methods and achieve similar things and achieve also robustness. And I'm going to talk about exponential moving averages and the different methods in using training stress balance when you calculate the training load and when you are dealing with more, as in this case, that's more consistent measure. And when you're dealing with more inconsistent measures like heart rate variability or something that you might not take on each individual day. So let's get started. First of all, I've been talking about problem when you have double sessions. So instead of averaging across the session, what you're interested in averaging across the days. So before averaging across the days, you need to kind of summarize sessions per each day. So if you're dealing with Power Pivot, there are two very interesting functions called SumX and AverageX. I won't go into details of how to use those, but just so you have the information that those can actually solve these problems, or summarizing and averaging, summarizing across the days, across the sessions within the day, and averaging across the days. Anyway, one particular problem, or actually assumption, is that with these methods, especially the second one, where I use the summary divided by 42 for chronic and summary divided by 7, the underlying assumption is that the missing days are or lack of data for a given day, it's actually 0. And again, these can backfire, especially if you are using measures such as heart rate variability or any other type of readiness measurement that you're not taking daily, or you're not supposed to take daily. In that particular case, it's better to use average. So you're basically averaging depending on how many inputs you have, instead of trying to average per day and assuming that missing data on a given day are actually 0. So that's very important. So in that case, I'll urge you to use actually average instead of summary divided by 7 or summary divided by 42, even if that's been shown to be more robust to missing data, because for missing data we are assuming that's a day off, so we are using that as a 0. Yeah, I've been playing a little bit with those two methods, and the main problem with using sum divided by 42, the pink color, the rose color, and sum divided by 7, is that it takes time to build up to get the actual baseline, especially for a chronic one. And one way to solve it is to use actually, instead of dividing by 42, you actually divide by number of days involved. So once you're building up and accumulating the data, you're not dividing by 42, you're actually dividing by number of rows that are, or number of days that are included in calculation. And in that particular case, for example, if you're on a day that's day 12, then we are dividing by 12, and we can use a row function. Basically, we are summarizing the rolling window and divided by number of events in that window. And that's only useful in the build-up phase. So when you have less data than the actual length of the rolling window. And what we achieved with this is actually we achieved same graph as in same graph as using average, but we are also more robust to a missing data, or actually we are assuming that missing data is 0. So let's delete some of the zeros. The top graph should change, the two bottom one shouldn't. So as you can see, the top one is rising up because it's disregarding zeros, and that's very important in calculating training load from daily inputs. Again, if you are using any type of readiness measurement, you still want to use average and actually average across the events that are actually in a database. So if I delete this one again, this is going to rise up even further. As you can see, the bottom graph is a combination of the two, one actually positives of two above graphs. So you have robustness of the second method and basically a speed of building up and getting more usable data quickly. And fourth method is actually using something that's called exponential moving averages. I've used a paper by Skiba and Clark to get the formula. Basically, with a rolling average, we are giving same weights for every data point. But with exponential moving average, we are giving more weights to recent scores. So kind of so the smoothing should be more reactive to a recent events, and that's the bottom one. As you can see, it's more smoother, and in my opinion, it doesn't react so well compared to the simple rolling, but it gets this smoother version. Again, this one is also robust to zeros. Let me see, because I use also method as in this one to calculate the average. So anyway, these are I will urge to use this method or exponential moving averages. Again, it's more art than a science, and you can experiment with different methods to get what's more suitable to your situation. And I'm repeating again, in the case of training load like GPS and session RPE or whatever you're using, missing data should be assumed to be 0. For inconsistent metrics such as daily readiness scores that you take once in a while, you should use the average, where missing data is treated as missing data. Thanks for watching, and see you soon.